Good morning, students. So today we'll be seeing about the second part of Unit 3. So we'll continue with the communication technologies of IIoT. We basically see about Bluetooth, BLE, and NFCs. So that is the today's agenda. So first we'll be seeing what is meant by Bluetooth. So Bluetooth is nothing but as you all know, it's short-range wireless voice and data communication. So it is a wireless personal area network technology, and it is used for data communications over smaller distances. So it was introduced, it was invented in 1994 by Ericsson. So it operates within the unlicensed business group, scientific and clinical ISM bands, specifying bands from 2.4 gigahertz to 2.48 gigahertz. So when you move to the distance, it considers distance from 10 meters. Okay, so depending on the meters, it is Bluetooth devices are connected. So depending upon the version, it represents the information at least up to 1 megabits per second or till 3 megabits per second. So Bluetooth network is called the Piconet, and it is nothing but it is a group of interconnected systems which is also called as scatternet. So Bluetooth is a wireless technology and that lets devices like phones, tablets and headphones which connect to each other, and it can share information without any need of cables. So Bluetooth simply follows the principle of transmitting and receiving data using radio waves, and where it can be paired with the other devices which also has Bluetooth, but it should be within the estimated communication range. So when you connect two devices starting to share the data, they form a network called Piconet, which we can further accommodate more than 5 devices. So this is a basic introduction about Bluetooth. So here we'll be seeing about the key features of Bluetooth. So the transmission capacity of Bluetooth is 720 kilobits per second. So when you consider the wireless communication of Bluetooth, so it is designed for short range data exchange between devices. And when you consider the transmission speed, it supports a data transfer rate up to 720 kilobits per second, which is also suitable for voice, audio, and low bandwidth data applications. So Bluetooth is robust and it is flexible, so it is cost effective and it is compact, and it is known for being low cost and it is ideal for short distance radio communication. So when you consider Bluetooth, this is the basic architecture where it can consider consumer electronics and other IoT devices, which is very reliable and adaptable. And Bluetooth can operate effectively in dynamic environments, and it can support various device types. So, considering the structure, the core unit of Bluetooth networking is the Piconet, so which consists of one master device and up to seven active slave devices we can have. Okay, so one master device which is connected to seven active slave devices, which enables coordinated communication within a small network. So, moving on to the architecture of Bluetooth, it defines two types of networks. So, as I told you before, if one is Piconet, the other is Scatternet. We'll see what is meant by Piconet. So, it's a basic Bluetooth network which consists of one master device and up to seven active slave devices. So this master device controls the communication, and it also controls the timing slot while slaves respond to its commands. So it is very simple and it is used for short range device interactions, and it can also connect a phone to a headset or speaker. And moving on to the scatternet, it is a large interconnected network which is formed by linking multiple piconets. So as I told you, I told you about piconets. which is nothing but it's a device, where one master device which is connected up to 7 active slave devices. So here when you consider a scatternet, a larger interconnected network which is formed by linking multiple piconets, so which where devices can operate in more than one piconet. So this acts as a bridge between them. So the advantage of using this type of scatternet is it enables broader communication, and it has more complex device coordination. So these are the architecture of Bluetooth. And next, moving on further, we'll see what is piconet in detail. So you all know the basic idea of Piconet. So we'll see in detail. So Piconet is a type of Bluetooth network. So as I told you, it has a master node and the slave nodes. So there are totally 8 active nodes which are present at a distance of 10 meters. So Piconet is a type of Bluetooth network that contains one primary node called the master node and 7 active secondary nodes. We call that as slave nodes. So the communication between the primary and the secondary nodes can be one to one, or it can be one to many. So possible communication between master and slave nodes are also possible here. So slave to slave communication is not possible here in Piconet. So it has 2255 parked nodes. So these are called the secondary nodes and cannot participate in communication. So unless it is converted into its active state. So these nodes do not participate in communication unless they are switched to active status by the master. So active status has to be given by the master. So this is the diagrammatic representation of Piconet. So as I told you, we have one master node which consists of 7 slave nodes. And moving on to these scaternets. Piconet is a fundamental Bluetooth network configuration which consists of one master node. So that we call it as a central controller that manages communication and timing. So a slave that is present in one piconet can act as a master, or we can say primary in another piconet. So here we have up to 7 active slave nodes. So secondary devices that communicate directly here. So either it can be connected one to one, or it can have one to many interactions. So when you consider the communication rules, only the master-slave communication is permitted, and slave-to-slave communication is not supported within a Piconet. So already I told you about parked nodes. So Piconet can include up to 255 parked nodes. So these are nothing but the devices that can be connected, but it can be inactive. So these nodes do not participate in communication unless they are switched to active status by the master. So this type of node is referred to as bridge node, where it can have a station and cannot be mastered in two piconets. So here we'll see what is meant by scatternet. So scatternet is formed by linking multiple piconets, so which creates a broader and more flexible for Bluetooth network. So here in this diagram we have 2 piconets, so which has one master node and other slave nodes. So we have 2 interconnected piconets here. So a slave device in one piconet can simultaneously function as a master in another. So it enables inter-network communication. This type of dual role device can receive data from the master of one piconet, and it can forward it to slave devices in the other piconet. So where it acts as the master. So such a device is known as the bridge node, which facilitates data exchange between piconets. And when you consider a single station, we cannot serve as the master in one more than one piconet at the same time, right? So this is all about scatter nets. And moving on to Bluetooth protocol stack, first we will be considering two layers here. First we'll see about the layers. So here we have a radio layer and the baseband link layer. So first we'll see about the radio layer. So it specifies the details of AI interface. It also specifies the frequency and frequency hopping, and it also specifies the transmit power. So both demodulation and modulation can be performed via RF signals. So when you consider radio layer, it defines the air interface specifications, which includes operating frequency bands, transmit power levels, and frequency hopping techniques to minimize the interference. So this all these things will be responsible for modulation and demodulating data into data frequency signals for wireless transmissions. So this establishes the physical characteristics of Bluetooth receivers, and it also supports two type of physical links. So one we can say like connectionless, which is used for broadcasting, and connection oriented for paired device communications. So when you consider baseband link layer, so this is considered as the digital engine of Bluetooth system. So it acts as a digital core of the Bluetooth system, and it is analogous to the MAC sublayer in traditional local area networks. So when you consider baseband link layer, it manages the connection setup within a Piconet. So it also includes device addressing, packet formatting, timing synchronization, and power control. So when you consider the communication, it ensures reliable communication between master and slave devices in the network. So this is all about the Bluetooth protocol stack, and we have the other layers like link manager protocol layer. So it performs the management which is already established links, which includes authentication and encryption process. So this layer is responsible for establishing, managing, and terminating connections between Bluetooth devices. So whenever it handles authentication, encryption, and link configuration, it ensures whether it is a secure and it is a stable connection. Stable communication. So it monitors the health of active links, and it gracefully disconnects them when commands are upon failure. When it is commanded or upon failure nodes. So when you consider logical link control and adaptation protocol, we call that layer as L2CAP protocol layer. So it is also known as the heart of the Bluetooth protocol stack. So it has upper layers and lower layers of the Bluetooth protocol stack. So it considers the Bluetooth protocol stack, which bridges the gap between upper application layers and lower transport layers. So it packages data from higher layers into format suitable for transmission, and it performs segmentation process also. So what is meant by segmentation? It is a process of breaking data into smaller packets, and it multiplexes the data. So handling multiple data streams simultaneously. So this protocol layer enables smooth and efficient data flow across the protocol stack, and it also supports diverse Bluetooth profiles and services. So when you consider device discovery protocol stack, so this is a layer which is used for short service discovery protocol. So it discovers the services available on the another Bluetooth enabled device. So this layer enables Bluetooth devices to identify and access available services on another Bluetooth enabled devices. So it also plays a vital role where it can establish functional connections, ensuring that devices it can discover compatible features before initiating communication. So moving on to RF communication layer. So this particular layer is for short radio frequency communication. So where RF communication is nothing but it's a serial port emulation protocol, so which is built on top of L2 CAP layer. So this protocol is based on ETSI standard, and the standard is given as TS07.10. So it provides a it provides a virtual serial interface where it supports legacy applications such as wireless application protocol, and it also supports OBEX where it is called as Object Exchange Protocol. So this protocol is based on ETSI TS07.10 standard. So it makes it reliable substitute for traditional cable-based serial communication. So it also supports point-to-point communication. So that in turn supports data exchange between Bluetooth devices. So next we have service discovery protocol. So moving on to the next layer, we have OBEX. So it is known as short object exchange. It is a communication protocol to exchange objects between two devices. Uh, so so moving on to the next layer, we have WAP. It is a short for wireless access protocol. So it is used for internet access, and we have TCS, which is called as telephony control protocol. So this is mainly used for telephony service, and it supports basic functions like setup and release, and it also supports group management for gateway serving multiple devices. So when you consider application layer, it enables the user to interact with the application. And next we'll move on to types of Bluetooth. So here we'll be seeing about the various types of Bluetooth that are available in the market nowadays. So first we'll be seeing about in-car headset. When you consider in-car headset, one can make calls from the car speaker system without using mobile phones. So we all use nowadays. So as you all know, we are using in-car headset, and next we have a stereo headset. So whenever we want to listen music in the car, so we use this headset, and it can also be used at home. And we have some other applications like webcam. So one can link the camera with the help of Bluetooth with their laptop or phone. And we have Bluetooth equipped printer. So the printer can be used via Bluetooth with the mobile phones or laptops. So we can take printouts. We have Bluetooth global positioning system. So here GPS are used in cars, and one can connect their phone with the car via Bluetooth to fetch the direction of the address. So moving on to the advantages, so Bluetooth is very useful. So it offers several compelling benefits. For example, like in wireless convenience, we have it eliminates the need for cables, making device interaction very seamless. So it can also penetrate through walls. So it can create an ad hoc connection immediately without any wires. So as I told you, it has low power consumption, which is ideal for battery power devices like wearables and sensors. Considering the universal compatibility, it is supported by virtually all modern smartphones, laptops, and other accessories. So it is also affordable to implement in devices, which helps in manufacturers with low cost. So when you consider the other advantages, ease of use, which is very simple, pairing the process with minimal setup is required. So security features includes newer versions, which also include encryption and authentication protocols to protect data. So these are the advantages. So when you consider the disadvantages, we have limited range. specifically with 10 meters. Some newer versions of Bluetooth can reach up to 100 plus meters. So this is a disadvantage of Bluetooth. So it has a slow data transfer rate of 3 megabits per second. So when you consider the interference, it operates in the crowded 2.4 gigahertz band, which cause signal disruption from Wi-Fi or microwaves. So slower data speed, transfer speed is also considered in Bluetooth, so which is not suitable for large file transfers compared to Wi-Fi or USB. When you consider pairing, the devices may fail to connect due to compatibility or firmware problems. When you consider the audio quality, in some wired audio fidelity, especially in high-end sound systems, it cannot match. So that can be a major challenge here. And next we have some security risk which is vulnerable to hacking if it is not properly secured. Though newer protocols have improved this, so we still have security risk. And moving on to the applications of Bluetooth, we have it can be used in wireless headsets, wireless pans, and local area network. So it can also connect digital camera wireless to a mobile phone. So it can also be used in consumer electronics. So it can have wireless headphones, earbuds, and speakers. We'll also use Bluetooth in mobile devices, which can be used for sharing between smartphones. We can also tether for internet access. We can also use Bluetooth for hand-free calling in vehicles. It can also be used in healthcare. For examples like glucose meter, glucose monitors, heart rate sensors, etc. So this is all applicable by Bluetooth-enabled medical devices. And we also have some other wearable health trackers that can also be used. These type of biomedical health cares can be used in sports and fitness, and it can be used in military. It can be used in automotive industry, in car infotainment systems. It can also be used in smart homes, or home automation, navigation and voice control integration, and so on. So other than this, we have so many benefits. It can also be used in industrial and retail. It can be used in asset tracking and inventory management, and we can also use this in beacon based location services. So these are the applications. And moving on to the next part, we are going to see Bluetooth Low Energy. So we call it as BLE. So BLE is nothing but it is a Bluetooth classic. So it specifies Bluetooth low energy. So we call it in short as BLE. So it is a short range wireless LAN communication technology standardized by IEEE 802.15. So Bluetooth can handle a lot of data but quickly consumes battery life. In order to rectify that, we go for Bluetooth low energy, which is used for applications that do not need to exchange large amounts of data, and it can run on battery power for years at a cheaper cost. We can use BLE commercially. So it was first accessible from year to 2011. So it is a low power consumption while maintaining the same communication range as in Bluetooth Classic. We can use this BLE in healthcare, fitness, security, and in home automation, and it saves power. We also achieve BLE to save power, and we can also use this in servers where we can transfer requests which is made by a slave profile. Considering the Bluetooth mesh profiles, it communicates with the other low energy devices in the network. So moving on to this, we have devices which can transfer or pass information to other low energy devices, which creates a mesh effect. So for example, we can say an entire building of lights from a single smartphone. So this we call it as a mesh profile, or we can call it as mesh networking. So this mesh models can be represented as MMDL. So this term model is used in mesh specification instead of profile to avoid unnecessary disturbances. So it operates within us operates in 2.4 gigahertz ISM, which is the unlicensed bandwidth. And next, moving on to the Bluetooth BLE specifications, we have some specifications here. So IEEE standardized Bluetooth is given as IEEE 802.15.1, but they no longer maintain the standards. So these Bluetooth versions from version 1.2 to 4.1, 4.2, 5.0, 5.1. These are the versions which is recently published. And when you consider Bluetooth low energy, it refers Bluetooth specification with version 4.1 and above. So when you have versions 4.1 and above, it is considered to be Bluetooth low energy. So BLE operates in license-free 2.4 gigahertz frequency band. So the channel frequency is nothing but 40 channels, and it has 40 channels in total, and 3 used for advertising and 37 for data transmission and reception. So when you cover the distance, it is maximum of 50 meters indoors and 150-meter outdoors. Here it employs GFSK modulation, and when you consider the data rates, so varying upon the Bluetooth version, it supports 1 megabits per second, and the modulation scheme is GFSK, and the output power is 10 dBm. And moving on to the device types, we have master and slave, and devices modes are considered to be dual mode and single mode. So single mode supports BLE, and dual mode supports both BLE and traditional Bluetooth. So we have wireless network modes which have point-to-point communication, and star topologies can also be followed. And moving on to the system robustness, it is adaptive frequency hopping, where it can have 24-bit CRC in the packet. So latency is 3 milliseconds. So sleep mode current is 1 mu A, and the security is 128-bit AES CCM. So these are the specific Bluetooth BLE specifications. And moving on to the next part, we have near field communication. We represent that as NFC. So NFC is nothing but it is a short range wireless technology, so that it enables communication between two electronic devices over a distance of 4 centimeters. For example, say 1.6 inches or less. We have as I told you before, NFC stands for near field communication. So mainly it is used for short range communication between compatible devices. So one transmit device and another receives the device, and it needs to transmit a signal. And many devices can use NFC standard, and it can either include passive NFC devices or active NFC devices. So when you consider passive NFC devices, so passive NFC device is nothing but the type of NFC where we have near field communication devices, which include stats and other small transmitters, so that can send information to other NFC devices without the need for a power source of their own. So when you consider these type of devices, these devices don't relay process any information which is sent from the other source, and cannot connect to other passive components. So these often may take the form of interactive signals on walls or advertisements. So when you consider the active NFC devices, these near-field communication devices can do both things. For example, like it can send and receive data. So they can communicate with each other as well as with the passive devices. So those type of communication is possible here in active NFC devices. So smartphones are the best example of active NFC devices. So card readers are used, so which is used in public transport, and it can be used in touch payment terminals, and it is a good example of those technology. And moving on to the next part, we have working of NFC. So here we can see the working. So it relies on inductive coupling. So it uses peer-to-peer mode, and it has two electromagnetic coils which is present on NFC enabled devices, for example like smartphones. So in this type of devices, we have two devices which switch between active when sending the data and passive when receiving. So data rates are from 106 to 848 kilobits per second, and NFC can be used for various purposes like including contactless transactions, data exchange, and simplified setup, or for more complex communications like Wi-Fi. So, so we have other modes that is also possible here. So third mode of operation is nothing but we call it as card emulation. So this NFC device can function as a smart or contactless credit card, and it can make payments or tap into public transport systems. When one of the connected devices has internet connectivity, data exchange can be possible. And this NFC standard currently has three distinct modes of operation to determine what sort of information will be exchanged between the data. So the second mode, I'll tell you again. So second mode of operation is nothing but read write mode, which helps in one-way data transmission, and the active device, possibly of a smartphone, for example, links up with another device in order to read information from it. So these are the applications of these three modes. So next we'll see the applications of NFC. So moving on to the data transfer, NFC can enable the exchange of small data packets such as contact, URLs or other files. So between compatible devices with a simple tap, it makes sharing quickly and it is very effortless. So when you move on to access control, NFC tags can grant access to buildings, public transports or events. So NFC tags can be programmed to grant secure access to buildings, or it can streamline entry and enhanced convenience. And moving on to smart pairing, so it simplifies Bluetooth pairing process by allowing users to connect devices instantly. These are all the applications. And next we have smart posters and tags. In embedded NFC tags and posters, it can also be used in packaging or advertisements, can deliver interactive content. So additional content can also be added, or it can be shared, where it uses user engagement and marketing experiences. So next we have benefits of NFC. So we'll see on the benefits one by one. So it is used for convenient transactions. So NFC enables quick and secure payments through smartphones. You can use all these with the other apps, making everyday purchase effortless and contactless. And we're moving on to the versatile applications. we have included a short range wireless technology where we can go for other applications and it can be used without any difficulty. So, considering the disadvantages, it is a small range and it considers only low data transfer rates. So this can be a challenge here. So high adaptation cost is also maintained in NFC. So the shorter distance we have from 10 to 20 centimeter. So despite these disadvantages, we have some widely compatibility connections where mobile payment systems can be used. When you consider costly adoption, companies find it expensive to adopt NFC enabled devices. So that's the major challenges here. So the data transfer rate is can be considered 106.212 or 424 kilobits per second. Uh, it is particularly it is particularly beneficial for mobile payments, data transfer, access management, and so on. Other than this, we have some advantages which includes reduced power consumption, ease of use, enhanced security, and so on. And some disadvantages is also there. So it's a short range, low data transfer rates, and adoption is a little bit costly, and it has some complex procedures. So that's all about today. So we have seen all these protocols. So we will also continue with the other three topics in Unit 3. As of now, we'll conclude with this. Thank you.